Hi, AICE. So let's begin by talking about research because what is this class? This class is a research-oriented class that has a little bit of psychology in it. So we have to know a vast amount of research methods and all the terms that correlate to it. These terms will be used throughout the entire year as we apply them to all 12 core studies. Got it? All right. So this is why there's so much vocabulary in this one section. So when we're talking about research, I know you've heard of the scientific method. Doesn't it remind you of 8th grade science class? The scientific method is still alive and well even when we're studying something like psychology. They often refer to psychology as a soft science because there's a lot of gray area. Things aren't always so black and white where they're so definitive, and sometimes there is no answer, and sometimes the answer leaves more questions. So there's a lot of gray areas. But I'm going to bring up a topic and we can apply it to the scientific method, shall we? Here's my topic. Do you think violent video games make you violent? That's a thought. Have you guys ever talked about that with your parents or had a little spirited debate about your use of video games, or maybe that you play too much, or maybe your video games are, kind of violent? Have you guys ever talked about that? Well, let's plug it into the scientific method. The scientific method, you're making an observation, and we could say kids play video games all the time. Like it's a very big part of people's lives. And um, it depends on the choice of video games that kids play. If kids play violent video games, do you think it contributes to their maybe bad behavior? So it can form a hypothesis. The hypothesis could be the more violent video games that a child plays, the increased likelihood they might react with violence when they're put under a stressful situation. Could that be a good hypothesis? And then I'd have to formulate an experiment to do this. So that's the question. Do violent shows or violent video games make kids aggressive? And this is an age-old question that's been kind of bobbing around since the onset of video games to begin with. Can we create an experiment in which we could test this hypothesis that maybe violent video games might give a propensity more to violence? Okay, so if we pretend like we're going to make a experiment with video games, we first have to know what are experiments for. Experiments are trying to find out cause and effect. We want to find out, does the violent video game cause the behavior of violence or aggression? And if that's the case, you have to have proper operational definitions. You have to work it all out, like define everything. And if we're going to do an experiment, it's important that we have to put everything in its right place. You have to have an experimental group and a control group for comparison. The experimental group will get the independent variable. That's the factor that you're manipulating. And if we're going to create an experiment in which we're testing violent video games causing violence, what's your independent variable? Did you say it was the video game? Because that is correct. Right, it's the video game. What's the dependent variable? If we're doing a pretend experiment on whether video games affect your behavior, what's the dependent variable? What are we trying to figure out? Right, do kids react more violently because they're playing the video game? It's the outcome of the experiment. It's the result of that manipulation. It's the outcome. What's the point, right? That's the dependent variable. Now, the experimental group is the one that you're going to put in that manipulated variable. They're the ones that are going to be playing those violent video games. And then the control group is not playing violent video games at all. Or, they might not be playing video games. It depends on how you set it up, but they could be playing other kinds of video games. They could be playing Pooh Bear's Great Adventure or Mario Kart or something that's non-violent. That would be a control group. Extraneous variables can ruin your experiment because those are variables that might affect the outcome or behavior that you're measuring, and so that way you wouldn't be able to tell cause and effect properly. Okay, so you're going to see the word operational definitions pretty much throughout our coursework, and that just means that you have to define something properly in order to, really define that dependent variable, measuring the outcome of what you're looking at. And if we're doing this pretend experiment of do violent video games make a child violent, we have to measure it. How would you measure it? You got to define it. Is it going to be physical violence? Does grinding teeth, does that constitute violence? Pounding, throwing the controller across the room, are we going to say that's violent behavior? It's almost like you have to have a checklist, like a checklist that defines certain qualities about a behavior that would deem it to be aggressive, okay? And that's operationalizing. So when we're talking about operational definitions, it's really important to define things. So I thought this Spider-Man meme was kind of funny because he says, so she says, don't call me anymore. So I go, can I text you? Can I friend you? Can I still talk to you in the hallway? Can I see you in the cafeteria? Like you have to define what it is when you say don't call me anymore, or like a breakup, or define it clearly so that the parameters can be followed. And so I just thought it was a funny meme. Okay, so when we're talking about research designs, there are three different kinds of experimental designs. The first one is an independent measure design, and this is when separate groups of participants are used for each experimental condition or level of the independent variable. They only encounter the experimental setting, um, and this avoids things like demand characteristic, like when the subjects do what they think that they ought to do, and that's not what you want out of a subject. You want them to act objectively and do what they're supposed to do on their own. And so independent measure designs tries to kind of eliminate those kinds of demand characteristics. Also, you have random allocation, and this is what spreads the possible differences between individuals across various levels of the independent variable. So that's one way that we can do an experiment, is an independent measure design, number one. Number two is a repeated measure design. When you're comparing the same person to their own baseline, they repeat performance under different conditions. And here's something that you need to also be aware of, are order effects. When a person does a test over and over again, they get better at it because they're practicing it, and that's called order effects. And that could be an extraneous variable for a design. And then last but not least, you can also have like fatigue effects. Like when someone does something over and over again, they might actually feel fatigued, or they might get better, which is like having practice at it, which also wouldn't be fair if you're trying to measure that dependent variable appropriately. And then lastly, you have matched pair designs, where the participants are arranged into pairs, and you're comparing the pairs in a performance on a test, or whatever it is that you're trying to find out. Now, there's different types of experiments, and actually, most of the experiments that we're going to encounter in AICE, the 12 course studies, most of them are going to be lab experiments, but you're also going to see a field experiment. But there are three types of experiments that you have to know, and this is what the textbook is going to talk about: lab experiments, field experiments, and natural experiments. Now, lab experiments sound like what they are. These are experiments that are conducted in a lab. They can be social experiments. They can have to do with animals. They can have to do with, biological factors like brain scans, etc. Those are all lab experiments. Field experiments are out there in the field, like you're doing something somewhere else. They're conducted in a more normal, typical environment. The bad part about field experiments is that they're harder to control, they're harder to standardize, and sometimes that might actually inflict some problems with reliability and validity. Now, natural experiments sometimes are considered not a true experiment because the researcher can't really manipulate any level of the IV. It's more like an investigation. You're just observing, in a natural setting, but you're not really manipulating anything. And some people would consider that not a true experiment. So those are your three types of experiments. Now I want you to watch this little video about experimental research. It really kind of helps break down what is IV and what is DV. And this is a quick video on correlational research, which tells you the difference between what is an experiment and what is a correlational kind of study. Remember, experiments are to find out cause and effect, where correlational research, they're just finding out what two things are related, if two variables are related. And remember, if you're having trouble accessing these videos from the PowerPoint, I'm going to post them individually in the module so you can access them there. Okay, really important when it comes to research, and we're going to be talking about this in depth, is ethics. When we do our 12 core studies, some of them, as you're reading them, you're going, should this have been done? Or like your eyebrow kind of raises a little bit and you say to yourself, is this, proper ethics? And if you feel that way, chances are, yeah, it's probably they might be breaching some ethical guidelines. Some of the experiments that we're going to be talking about took place before strict ethical guidelines even were designed. They took place like in the late 50s and 60s, and they didn't have such strict guidelines like they do today. Here is the rule of thumb for ethics in research. Number one, you have to have voluntary participation. You can't force someone to do something. And you have to have informed consent. Like the people have to know that they're doing an experiment. No harm can come to the individual or subject or anyone involved in the experiment. And then there's something they call PAC, P-A-C, privacy, anonymity, and confidentiality. You can't like run around telling people, oh, so and so got a score of this, and point and laugh. There should be no humiliation happening, because that falls under the no harm should be done. Now, also, there's obviously things like professional kinds of ethics breach, like giving credit where credit is due, plagiarizing, saying something is your idea when it's not really your idea, or you got it from someplace else. So there's those kinds of ethics as well. And in psychology, you see a lot of social experiments that literally can't be done unless you lie to the subject. Like, you have to lie. Some form of deception is allowable so long as no harm comes to the person, especially permanent damage. But even short-lived damage is questionable. But there has to be something done if you lie to them. Want to guess what that is? Yeah, it's the D word. It's debriefing. After you deceive the subject, after this social experiment is over, you have to tell them the true nature of the study. And let's face it, there's some psychological experiments that you need to deceive, or else it wouldn't work. And we're going to see a couple of those as we move on in our coursework. So this is kind of like a quick float chart on the ethics and what you have to know about ethics. Okay, so I'm helping you out here defining some terms regarding research methods. You have self-reporting and questionnaires. Self-reporting is when you're asking participants to provide information about themselves, like filling out like a survey. And then you've got questionnaires. In your life, you've done a bunch of questionnaires. So I'm pretty sure that you're familiar with that. You have to know what a closed question is versus an open question. A closed question is like a fixed set of responses, like a multiple choice question, or like a yes or no kind of question. Now, an open question is going to ask you for descriptive kinds of answers. What do you think about this? Or, tell me your feelings about something else. Those are open-ended questions, and usually there's more discussion there. There's evaluating questions, which they're gonna analyze things because they're evaluating a point. Now the problem with questionnaires is that two different researchers may interpret the information differently, and that's called inter-rater reliability. Two people also might not tell the truth when they're answering out loud, and that might have to do with social desirability. Like if you have to say something out loud, a person might not actually do that objectively because they don't want to be embarrassed or they want to answer what everybody else is answering. But if you look at the bottom here, I'm going to highlight in blue. These are all the different kinds of interviews. They're structured, unstructured, and semi-structured. And then you have evaluative interviews, subjective and objective. Subjective means personal viewpoints could be biased, but objective is like a test. There's a right or wrong answer, and if you get it right, you're right. If you get it wrong, you're wrong. There's no gray area in between. All right, so a case study is when you have a detailed investigation of a case or an instance involving a subject. They could be highly valid, although they're not replicable. Remember, there's a lot of case studies involving abused children, but you're not allowed to take a child and abuse a child to find out the effects of what child abuse does on a reading ability or on your anxiety levels or depression. Like that would be completely unethical. But what we can do is study kids who have experienced abuse, and then we can see the outcomes of that abuse. That would be considered a case study. And it really depends on the researcher's interpretation, which sometimes can be biased. In a longitudinal study, remember, longitudinal studies could be years and years in the making, where you study someone from the moment that they're born all the way through adulthood. I mean, that could happen in these long studies. A researcher may develop relationships with participants and subjects, and that could also lead to bias. And you can use observations and interviews and questionnaires to gather more data. But remember, a case study is special because you're studying one individual person and it could be for a long time. And then you're assuming that what happened to that individual might happen to others. A famous case study in psychology is the study of Phineas Gage. And he was a man that was working on a railway station and got a rod that kind of shot through his like chin and it went up and out the frontal lobe. And because of his study, we know today what the effects are on frontal lobe injuries. People cannot critically think very well or plan. They might act immature. And Phineas Gage, before his accident, was a very responsible young man. He held a job. He was actually the foreman of the railway station. He gave people jobs. He was the one that assigned the paychecks. Then after his accident, he became completely irresponsible. He was using curse words and being kind of rude and just not the usual Phineas. We learned a lot about the frontal lobe and what can happen when someone sustains frontal lobe damage from that case study that happened a long time ago. Now, can you do that to a person? Of course you can't. That violates ethics. But can we study a person that had an accident like that? Yes. So case studies can be valuable that way. I love concept graphs. I use them all the time. And for the visual learner, I hope this helps. But I have kind of organized the different words that you need to know about research. You have the word overt and covert over here in the left-hand corner. Overt means that the role of the observer is obvious, and covert means that you are using deception or some kind of disguise. That's the difference between overt and covert. Now there's different observations, and observations are here, and there's 4 different kinds. You have unstructured, naturalistic, structured, and controlled. And I've defined all those for you, so I'm kind of giving you different kinds of observations. And then up here in the green box above my head, we have different kinds of categories. Behavioral categories, like activities recorded in an observation, like you're recording behaviors. inter-observer reliability, consistency between two researchers and what their opinions are, participant observations, which means that you're participating in whatever it is that you're doing, and then you have non-participant observation, where you're not messing with the subjects, you're just watching them. Okay, so if you can't access this video from the PowerPoint, I will definitely post this in modules so you can check it out. I want you to ask yourself, this is an experiment on bystander effect. A little actress named Raquel is going to pretend to get abducted on the streets of New York, and you're going to watch people walk on by and not do a thing. Do you think this experiment is valid and reliable when it comes to bystander apathy? Why aren't people helping? Like, what is going on here? Why are people watching this girl get abducted? And do you think this reflects real life? So after you watch that video, I want you to ask those questions to yourself. And then I want you to answer the question, what kind of observation is this? This is such an important word in psychology, and the word is correlation. Correlation does not mean causation. It's so important that we know this. Here we go. Correlation just means relationship, right? And there's different kinds of relationships. You have a positive correlation and a negative correlation. I always use the example of more money, more problems. My two hands go up, right? More money, more problems, that's a positive correlation. More money, less problems, that's a negative correlation. So when one thing goes up and the other thing goes down, that's negative. When two things goes up, that's positive. And I use the money and the problem example all the time. But down there, actually, there you go, I'm pointing at the scatter plots. These are scatter plots that show a negative correlation, a zero correlation, and then a positive one. The negative correlation is talking about auto mileage right here and auto value. It has a negative correlation. We all know that the more miles on your car, the less it's going to be valued. Am I right? So it has a negative correlation. When one thing goes up, auto mileage, the other thing comes down. Now, here is a zero correlation or no correlation, auto quality, and then the auto body of the car. Are red cars better than blue cars? No. Color has nothing to do with the quality of the vehicle. So it has zero correlation. And on a scatter plot, it's going to look like this. Lastly, we have a positive correlation, auto accidents and auto insurance cost, right? The more accidents you get in, right, the more it's going to cost. One thing goes up, the other thing goes up. Am I right? The more accidents you get into, teenagers, the worse the cost will be for your insurance. That's a positive correlation, up and up. You guys got negative, zero, and positive correlation. Now, there's such a thing called a coefficient correlation, which is a numerical value to this. And you have to know that zero means no correlation. One is a perfect positive, and negative one is a perfect negative. And all the numbers in between are kind of gradients of that value. Okay, so here's the example of what I was saying about the coefficient correlation. It's a perfect negative, it's right here. Perfect positive is right here. And then everything in between. And this would be no relationship at all. Good? Does that picture help? And here are some more scatter plots that help you understand perfect positive correlation and a strong positive correlation. Here's a perfect positive correlation. And here's a strong positive correlation. And here's a weak one. Kind of looks like that starry night right here. Here's no correlation. The more kind of starry night it looks like, the less of a correlation it has. Here's a weak negative over here, and a strong negative, and then a perfect negative over here. Sorry I'm blocking that, but I think you got the picture right. So scatter plots tell the story of correlation. Study sounds like what it is. That's the purpose of the study. What's the point? The hypothesis is a testable statement or prediction that you're making. And in the core studies that we're going to be seeing in the future, there might be several hypotheses. There also might be several independent variables in each study. So we have to get ready for that. It's also your job to know the difference between a two-tailed research hypothesis and a one-tailed research hypothesis. And I want you to read right above my head, this finger, right here, what that is, right? A one and two-tailed hypothesis. And remember, when you're writing, they're broadly written in the same way the experimental hypothesis, except we're predicting a relationship. We're not predicting necessarily a difference. A two-tailed research hypothesis could be there'll be a significant correlation between the achievement in Cambridge psychology and attendance in psychology classes. A one-tailed research hypothesis could be there'll be a difference between, there'll be a significant positive negative correlation between the achievement in AICE psychology and the attendance in psychology classes. So let's do a scenario together. Let's go on to the next slide and practice. Okay, let's do some practice examples of non-directional and directional hypotheses. And let's talk about types of chairs in school and your personal work rate. Have you ever given that any thought? Like, if you had actually more comfortable chairs in school, would that increase or decrease productivity? So let's look at the different ways that we can look at this topic. And the aim here is to explore whether hard or soft chairs help students work better in school. A non-directional two-tailed hypothesis would be something like this. There's a difference in work rates of students sitting in comfortable chairs and uncomfortable chairs. Now it's non-directional two-tailed, right? A work rate difference of students sitting in comfortable chairs and uncomfortable chairs. See the two tails? Okay. A directional one-tail hypothesis would say students on comfortable chairs will have a higher work rate than those sitting in an uncomfortable chair, right? So you have the one-tailed hypothesis saying that those that have comfortable chairs will have a higher productivity rate. An alternative hypothesis, which would be directional, would be something like comfortable chairs will have a lower work rate because students will be lazy and they might get sleepy. And then a null hypothesis would be basically saying that it has nothing to do with chairs, right? Any difference in work rate of students sitting in soft or hard chairs has nothing to do with work productivity. You guys got it? Okay, that was a practice. And the example was chairs and school work rate. Now, it's really important to have good standardization. And in every of the 12 core studies that we're going over, that's one of the main things they always ask us. What's the standardization? Like, what are the things that make this a great experiment? Well, does it have proper operational definitions? Are they defining everything? And are there any confounding or extraneous variables? And remember, extraneous variables can ruin an experiment. They confound, they confuse the results, and it can work against the effect of the independent variable. Now, a pilot study is a preliminary test. They can do a study before an actual study. They call that a pilot program or a pilot study. There's something called situational variables, which are things in the environment that can cause confounding variables, like the colors in the room, the temperature of the room, the noise level, the lighting, the people around you. Like, did you sleep last night? There's so many things that can confound or confuse or affect an experiment. And those are all called situational variables that lead to confounding variables. And there's something also called uncontrollable variables versus controlled. Now, an example is allowing students to choose the chair they work in, soft or hard, that may affect the results of like the productivity level. Now, lazy students, it may actually want a comfy chair. They might work less because they're lazy. But what if you're hardworking and you could still use that comfy chair, but you use it for higher productivity? Um, there's some variables that you can control and not control, and it's really your job when you start learning the 12 core studies to be able to point them out. And that's what I mean about ripping apart the study. They expect you to look at a study and just tear it up, just like look at it in all different kinds of ways. That's a lot of critical thinking. So Cambridge has a lot of faith in you to do so. Okay, a good experiment always has good sampling, and the word of the day is random. Is it randomly sampled? That's the best kind of sampling. And remember that I have it here for you in an image. A population is looking at everybody, right? But can we really test everybody? No, we can't test everybody. We have to test a sample of the population, like a smaller portion, a microcosm of society, and that reflects the rest of society. So remember that there's a couple of different types of sampling. Some are better than others. Opportunity sampling are participants that are chosen because they happen to be at the right place at the right time. And sometimes we're going to see experiments like that in our 12 core studies where they took people and they tested them because they happen to be in the same building or they were coming out of another study and they were like, hey, you want to join another study? And that's how it worked out. Those are called opportunity sampling. It's not their very best choice, but sometimes when you don't have a choice, you kind of go with it. That's one way. There's also volunteer sampling. They're invited to participate. Maybe you send an advertisement out there. They do that in radio stations. They'll say like, hey, do you have acid reflux? If you do, call University of Miami. They're conducting a trial on, acid reflux reducers or some kind of medication. They put like information out there and then like people volunteer to do the study. Not bad, not bad at all. Now, random sampling is the best kind of sampling because everybody in the entire group has an equal chance of participating. And so it's completely randomized, tends to be the very best result. Now, a lot of kids confuse these two together. So I'm going to take my blue marker and I'm going to go like this with these two words. There's a difference between random sampling and random assignment. Random sampling is we randomly take out of the population, right? But random assignment means that you randomly put who's going to be in the experimental group and who's going to be in the control group. You randomly pick those out, like one potato, two potato, like out of a hat. That's the best way to do things. All right, so that's a little bit about sampling. I hope you understood that, and I hope my image is above my head. I hope those help. Okay, here's a quick graph on sampling techniques, and I point out here the strengths and the weaknesses. And you're, of course, filling in your guided notes. And these are the strengths and weaknesses of both opportunity sampling here, volunteer sampling, and random sampling. So for those of you who like that visual of the concept graph or the chart, here you go. Okay, let's talk about different kinds of data. You have qualitative data and you have quantitative data. Now I want you to look at the word quantitative. Does it look like quantity? Quantitative. When you look at the word quantitative, I want you to think of numbers because that's what it's about. It's about exact measurements and it's about numbers. Qualitative data talks about more of the detailed information about data. Details. So qualitative is like the quality of the data, right? So are they both important? Absolutely. Now, when it comes time for measurement, you want as much quantitative data as possible. But what gives depth to the information in the data? That would be qualitative data. Now here is a great little chart that gives you the strengths and weaknesses of both quantitative and qualitative data. And in our 12 core studies, we will be experiencing a little bit of both. And your job will be to look at a study and point out what is the quantitative data, like the numbers, and what is the qualitative data, like the depth of the information. Okay, also, as we go on with our 12 core studies, we're going to be exposed to graphs and charts in this study, especially at the end when they show the quantitative data. They're going to want to show us in the form of graph and charts. You got bar charts, which are over here. This is a histogram, and we're also going to see scatter plots. But I've noticed that Cambridge calls them scatter graphs. Doesn't matter, they're scatter plots. And this is where you're going to see a lot of correlational studies. I think a very big part of what we're going to be experiencing are both scatter plots and bar charts. And we really have to get a really firm grasp on normal bell curve distribution. And here I have a normal bell curve. Now I'm going to take my blue marker right here and I'm going to show you. See this right here? It's a bell. This is why it's called the normal bell curve. It has kind of like a bell shape, you see? And over here I have the extremes. And let's say we're talking about grades in school, right? This is what grades in school are supposed to look like. They're supposed to follow the normal bell curve. Most kids are around the average right here. Few kids are scoring exceptionally high and also exceptionally low. And I'll be quite honest, I've been teaching psychology, like advanced psychology, for many years now. And I got to tell you that my grades don't look like this. I have more kids getting A's and B's and then C's with few D's and F's. So my curve doesn't look like a normal bell curve. I'll make it in green. It looks more like this, where I have few A's, a whole lot of B's, and a lot of C's, and then very few D's and F's. So it kind of looks like that. It's not a normal bell curve, right? It's a skewed bell curve, they would call that. And the whole point in knowing what these things are is that we have to kind of like understand that most things happen along the median or the middle or the average, and few things happen on the extreme. Let's look over here. I'm going to take my purple and I'm going to point out, here's the normal bell curve for IQs. Here it is. Most people's IQ is right here along the middle, average being 100 right down the middle. And then few IQs are on the extreme. Here's the disabled, and here is people who would be considered gifted. And that's life. If you look at life, let's talk about talent, for example, singing talent, right? And I'll use this chart over here. Singing talent, few people are disabled, right? Where they can't even hum a tune and they're like impaired, right? Few people can't even hum a tune. Most people are around here, around the average. They can hum a tune. And then you have few people, the exceptions, with those like 8-octave ranges, like Ariana Grande. She's got like an 8-octave range. There are few people like that in the world, the gifted people of the world. That's over here. And what the normal bell curve is really showing us is that in life, most things run along the average, along the mainstream, with few exceptionalities, both low and high. That's the normal bell curve. Normal bell curve distribution shows us that. Now, as we learn more about measuring differences, let's go to the next slide. It's always good to be able to look at a chart or a graph and be able to decipher the data. The three words that you see the most in statistics, especially with psychology, is you're going to talk about mean, median, and mode. And here's a very quick way to remember these three. Mean means average. Median, think of a median in a street, right? The median is that thing in the middle that divides the street straight down the middle. So think of the median as being the middle. And then mode. I always think of MO and MO, right? Mode, MO, and most. That's the number in a data lineup that will occur the most. These are the three most common questions that you'll get in statistics, and very rarely, if ever, do you ever have to calculate anything, which is very good news for me. You have to know the definition of range. Range is the difference between the highest and the lowest score of distribution. And standard deviation means that there's an average difference between each score and the average or the mean. Okay, so there's a low standard deviation and a high standard deviation. And I want you to check out these charts. That fat curve means, let's pretend we're talking about grades, right? If this is grades, that means I gave a test, right? And some kids scored as low as 35, 40% on the test. Then I had kids scoring along the average, like, 75%. Then I had some kids score as high as like 98, right? That's having a high standard deviation. A fat curve means that there's a wider spread of the grades away from the mean and average. But a thin curve means it's over here. A thin curve means that most of the scores are close to the average right here. That means that 75% that most kids scored along the range of average. There weren't really like high grades and there weren't really low grades. They're too low. They were all pretty much in that same area. So what does standard deviation tell us? It's a measure of dispersion. It measures how spread out the data is from the average. The further the data spreads, the greater the standard deviation. And if you want to see a quick YouTube video on standard deviation, there's a link down here, and I'm just going to point it out in yellow, that you can cut and paste on your browser, and that also might help understand standard deviation. Now, here's something that really confuses kids. And in this case, when we're looking at these charts, I want you to pay attention to the tail. When I say tail, I mean this right here. I'm going to highlight it in blue. This is the tail. When the tail is right, this is considered a right skewed or positively skewed distribution. When the tail is left skewed is a negatively skewed distribution. Now, when it's a negatively skewed distribution, that means the majority of scores are above the mean, right? And if the mean is right here, that means that the majority of scores are above the mean. The right skewed or positively skewed distribution means that the majority of scores are below the mean. Got it? All right. All right, let's talk about ethics one more time. It's important to have ethical considerations for both humans and animals, and these are what you have to remember about ethical considerations with humans and ethical considerations with animals. And you know what? I know a lot of people say, well, we shouldn't use animals in any kind of animal testing. And I feel you because I love animals too. But you have to remember that in the studies that we are going to experience together, there's a couple of animal studies, and they're really careful with ethics. What kind of housing that they're in? Do they put them through any kind of hurt or harm or pain? And the answer, thankfully, for the most part, is no. And we have to kind of keep in mind that for the sake of science, they will use animals for some kinds of testing, as well as they use humans. And we'll see a bunch of those as well. Okay, Ace, we are officially done with this chapter. So now your job is to study and prepare for the research test. Now, yes, we did not see any course study in this section because we have to learn the words first. But all these words from the research chapter, from this chapter, we're going to see them later. 12 times we cover the 12 studies. So it's important that you have a good handle on this. Don't forget to go to modules and do that pull down tab, the one that says review, and check out the different reviews I have there for you to study research and the research terms. And then when you're ready and when the time comes on the due date, you click on the quiz or test links, and then you do your test for research. It'll be there. It'll be a multiple choice exam, and I'm sure you will do absolutely fabulous. And if you know these words, then the rest of 12 studies, you'll be able to apply them appropriately. Okay, ACE, congratulations. 1 down, 12 to go. Woohoo!